Hi, Assalamualaikum warahmatullahi wabarakatuh. Today we would like to present about external interconnection standard. First of all, let me introduce to you guys my team members. So the first is which is me, Dayanku Nabila Maisara binti Awang Muhammad Fendi, and here is Sofia Rafisa binti Muhammad Ramli, Siti Zulaika binti Saleh, and also Siti Yulaiha binti Abdullah. In this content, we would like to talk about definition of external interconnection standard, importance in digital landscape, seamless connectivity, types of external interconnection standard, importance of standardization bodies, challenges and future trends, and also conclusion. Basically, external interconnection standards are specification and rules that specify how different electronic devices, systems, or components can connect and communicate with one another. These standards are critical for assuring the compatibility, interoperability, and seamless interaction of various hardware and software products from multiple vendors. Physical connectors, electrical properties, communication methods, and data transfer formats are all covered by external interconnection standards. They act as a common language, allowing devices and systems to communicate and collaborate successfully. These standards make it easier to design and operate a diverse range of consumer goods, computer peripherals, networking equipment, and other associated technologies. Manufacturers can develop products that are universally compatible by following two external connector standards, allowing users to mix and match components from different brands without facing compatibility concern. To maintain uniformity and widespread adoption across the technical ecosystem, industry groups and standardization bodies often oversee the development and maintenance of this standard. The importance of external interconnection standards in the digital landscape is significant and multifaceted. Here are several key reasons why these standards play a crucial role. The first one is compatibility and interoperability. External interconnection standards ensure that devices and systems from various manufacturers can communicate with one another. This improves interoperability by allowing users to connect and utilize different components without having to worry about compatibility issue. The second one is consumer convenient. Consumers may choose and use electrical devices more easily thanks to standards. Adherence to standards streamlines the user's experience, whether it's connecting a printer to a computer or using a universal charger for many devices. The third one is innovation and competition. By establishing a shared foundation, standardization stimulates innovation. Manufacturers can communicate on enhancing performance, functionality, and user experience while adhering to defined guidelines. This encourages healthy competition and accelerate technical innovation. The fourth one is market expansion. Standardized interface and protocols promote market growth by allowing a varied range of products to coexist. This promotes a larger ecosystem in which consumers have more options and manufacturers can specialize in specific components or functionality. Last but not least, global connectivity. Standards enable global compatibility, allowing devices and systems to connect effortlessly across boundaries. This is especially vital in an age of digital communication and global supply networks. In summary, the importance of external interconnection standard in the digital landscape lies in their ability to create a harmonized and interconnected ecosystem, fostering innovating competition and a better experience for consumers and businesses alike. The capacity of devices and systems to connect and interact with one another in a smooth, uninterrupted manner is referred to as seamless connection. This idea is strongly related to the use of external connectivity standards, which give a common set of requirements and norms for various technologies in order to assure compatibility and easy communication. The purpose of seamless connectivity is to improve the user experience by removing obstacles, decreasing complexity, and allowing devices to work seamlessly together. There are a few aspects of seamless connectivity, which are plug-and-play functionality, interoperability, automatic configuration, adaptability, and user-friendly experience. This technology allows users to connect a wide range of devices, such as printers, cameras, laptop, and also smartphone, with minimal effort and without compatibility concern. Seamless connectivity is a key driver in making technology more accessible, convenient, and user centric. External interconnection standards come in various types, covering different aspects of connectivity between electronic devices and systems. Here are some common types of external interconnection standards. The first is physical connectivity standards, which are USB, Universal Serial Bus, HDMI, High Definition Multimedia Interface, Ethernet, and Thunderbolt. And the last one is wireless connectivity. There are Bluetooth and also Wi Fi.
USB, or Universal Serial Bus, is a widely used interface standard for connecting various devices to computers and other electronic devices. USB ports are common on computers, laptops, and many other gadgets. USB supports hot plugging, meaning you can connect and disconnect devices without restarting the computer. USB connector also come in different shapes and size, and USB is not limited to data transfer. USB is widely used across various applications for connecting and powering devices. Some common applications include peripheral devices, smartphones and tablets, external storage, audio devices, and power banks. The versatility and widespread adoption of USB make it a standard choice for connecting and powering a diverse range of electronic devices. Certainly, here's a concise overview of the evolution of USB from USB 1.0 to USB 4. USB 1.0, the data transfer rate is 1.5 Mbps for the low speed and 12 Mbps for the full speed. It is primarily used for connecting peripherals like keyboards, mice, and printers. USB 2.0, the significant speed boost is 480 Mbps. It is widely adopted, expanding USB usage for various devices. USB 3.0, the substantial speed increase is 5 Gbps, introduced as super speed and improved power management. USB 3.1, the data transfer rate is 10 Gbps, featured the reversible USB Type-C connector. USB 3.2 combine lanes for up to 20 Gbps data transfer speeds, maintain compatibility with USB 3.0 and 3.1 devices. USB 4 integrated Thunderbolt 3 technology, supported data transfer rates up to 40 Gbps, enhanced video and data capabilities. Each USB iteration brought improvements in speed, connectivity, and power delivery, making USB a versatile and widely adopted standard for connecting and powering a diverse range of electronic devices. HDMI, which stands for High Definition Multimedia Interface, is a widely used digital interface for transmitting high-quality audio and video signals between devices. It was first introduced in 2002 as a successor to various analog video standards. is known for its ability to carry both uncompressed digital audio and video signals, providing a single cable solution for connecting different types of electronic devices. Here's an overview of HDMI versions and some of the key features associated with each. HDMI 1.x or 1.0 initial release, supporting basic high definition resolutions and supported video resolutions up to 1080. HDMI 1.4 added support for 3D content, allowing the transmission of 3D video. Introduced the Audio Return Channel (ARC), enabling audio to be sent upstream from a TV to an AV receiver without the need for a separate audio cable. HDMI 2.0 increased bandwidth to support higher resolutions and refresh rates, supported video resolutions up to 4K at 60 Hz. HDMI 2.0A added support for high dynamic range metadata signaling, allowing better compatibility with HDR content, and HDMI 2.0B added support for hybrid log gamma HDR. HDMI 2.1, a major update with significantly increased bandwidth, supported video resolutions up to 8K at 60 Hz and 4K at 120 Hz. Each HDMI version has brought advancement to accommodate higher resolutions, improve color representation, enhance audio capabilities, and features catering to evolving consumer needs, particularly in areas like gaming and HDR content. The version numbers are indicative of the standard's continuous evolution to support the latest technologies and trends in audiovisual experience. HDMI is used in various applications for transmitting high-quality audio and video signals. Here are some common use cases of HDMI. First, home entertainment system, computers and monitors. Next, projector, streaming devices, education, and virtual reality (VR). These use cases highlight the versatility of HDMI in various industries and settings, providing a standardized interface for transmitting high-definition audio and video signals.
Ethernet is defined as a networking technology that includes protocol, part, cable, and computer chip needed to plug a desktop or laptop into a local area network for speedy data transmission via coaxial or fiber optic cables. It is also a widely used communication technology that enables devices within a local area network to connect and communicate with each other. It serves as the foundation for wired networking and facilitates the transmission of data between devices like computers, servers, printers, and other peripherals. Ethernet plays a pivotal role in a local area networks, forming the backbone of communication within these networks. Its significance lies in several key aspects like connectivity, speed and bandwidth, data transmission, and cost effectiveness. Ethernet speeds and variations. Ethernet technology has evolved significantly since its inception, offering various speeds and iterations to accommodate the increasing demands for faster and more reliable data transfer. Here's an overview of some of the Ethernet speeds and variations. Number 1 is 10 Mbps Ethernet. This was the original Ethernet standard, offering a data transfer rate of 10 megabytes per second. It utilized twisted pair copper cables and operated on a baseband transmission method. And number 2 is fast Ethernet. Fast Ethernet, also known as 100 base T, increased the data transfer rate to 100 Mbps. It maintained compatibility with existing Ethernet technologies but provided a tenfold increase in speed. It's still used in some legacy systems today. Number 3 is Gigabyte Ethernet. Gigabyte Ethernet, or 1000 base T, operates at a speed of 1 gigabyte per second, 10 times faster than fast Ethernet. It became widely adopted in both consumer and enterprise networks, offering significantly increased bandwidth for data-intensive applications. And the last one is a future Ethernet standards. Ongoing advancements in networking technologies continue to push the boundaries of Ethernet speeds. Standards for speeds beyond 100 gigabytes and developments like 200 gigabyte Ethernet and 400 gigabyte Ethernet are being developed to meet the ever-increasing demand for faster data transmission. Ethernet versatility, scalability, and continued evolution have made it a dominant force in networking, providing various speed options to suit different applications from home networks to large-scale enterprise infrastructures. Thunderbolt is a high-speed connectivity standard developed by Intel in collaboration with Apple. It combines data transfer, video output, and power supply into a single compact part. Initially introduced in 2011, Thunderbolt was created to address the need for faster and more versatile connections between devices. Key features and aspects of Thunderbolt includes speed and bandwidth, versatility, daisy chaining, compatibility, Thunderbolt 4 and use cases. Thunderbolt data transfers and display capabilities. Thunderbolt technology offers impressive data transfer capabilities and robust support for display connectivity. The data transfer and display capabilities of Thunderbolts are among its most notable features. Number one is data transfer speeds. Thunderbolt provides exceptionally fast data transfer speeds. And number two is support for multiple protocols. Thunderbolt supports various protocols simultaneously, including PCIe. It is a peripheral component interconnect express for data transfer and DisplayPort for video output. Number 3 is daisy chaining displays. Thunderbolt's daisy chaining capability allows users to connect multiple Thunderbolt compatible displays in a series using a single Thunderbolt port on the computer. Number 4 is backward compatibility. Thunderbolt ports are backward compatible with DisplayPort's connectors, allowing Thunderbolt-equipped devices to connect to non-Thunderbolt displays using appropriate adapters or cables. And the last one is external GPU support. Thunderbolt ports can also be used to connect external graphics cards to laptops or desktops, enhancing graphical performance for demanding tasks such as gaming, video editing, or 3D rendering. Adoption in high-performance devices. Number 1 is professional workstations and laptops. Number 2 is external storage solutions. Number 3 is displays and monitors. Number 4 is external GPU enclosures. Number 5 is docking stations and hubs. And the last one is professional audio or video interfaces.
Bluetooth is a wireless communication standard that enables short storage data exchange between devices. It operates on the 2.4 GHz frequency and support various profiles for different applications such as audio streaming and file transfer. If you can see, you can use 4 applications for Bluetooth. The first one is printer. Bluetooth enable printers eliminate the need for per-cycle connection, enable wireless printing from devices like smartphone and tablet. Second one is IoT. IoT is the meaning of Internet of Things device. The first one is home automation device. Bluetooth is utilized in smart home devices like lights, thermostat, and security system for seamless control and automation. Next, medical device. Medical device is health monitoring device. Why? Because Bluetooth connectivity is employed in devices like blood pressure monitors and glucose meter for wireless data transfer to smartphone or other monitoring system. Next is automotive. Hands-free call. Why? Because Bluetooth is commonly used in car for hands-free communication, allowing driver to make calls without holding their phones. And then this application highlight the versatility of Bluetooth technology across various domains, enhancing the wireless connectivity and use experience in a wide range of devices. Now, move to the Bluetooth version and improvements. The first one is Bluetooth 1.0. The initial version of Bluetooth had limited data transfer speed and a maximum range of about 10 meters, primarily used for basic wireless audio and data connection. Bluetooth 2.0 plus EDR. EDR is enhanced data rates. Introduced in 2004, this version increased the maximum data transfer rate up to 3 Mbps, improving the efficiency of data transmission. Enhanced data rate was a significant improvement for multimedia application and file transfer. Next is Bluetooth 3.0 plus HS. HS is high speed. This Bluetooth released in 2009. This version introduced the high speed feature using Wi-Fi technology for faster data transfer rate, especially for bulk data transfer. It maintained backward compatibility with Bluetooth 2.1 plus EDR. Next is Bluetooth 4.0 is Bluetooth Low Energy, also known as Bluetooth Smart. This version introduced a low power mode, making it suitable for devices with limited power resources, such as fitness tracker and IoT device. Next is Bluetooth 4.1. This Bluetooth improved consistent with long-term evolution and introduced better data transfer efficiency. Next is Bluetooth 4.2. This Bluetooth enhanced privacy and security features, including increased encryption key length, IoT enhancement, improvement support for IoT device, and IPv6 connectivity. And the last one is Bluetooth 5.0. This Bluetooth four-times the range of Bluetooth 4.0, allowing for better coverage and high data transfer speed, double data transfer speed compared to Bluetooth 4.0. And then Bluetooth versions continue to advance, addressing the growing demands of wireless connectivity across a wide range of devices and applications. Wi-Fi is short for wireless fidelity. It refers to a set of wireless networking technologies that allow device to connect and communicate without the need for cycle cable. Wi-Fi standards are defined by the Institute of Electrical and Electronic Engineer and identified by numbers such as 802.11n, 802.11ac, and so on. If you can see at slides, the first one is 802.11ac. Is a wireless networking standard in the 802.11 set of protocol. It is commonly known as Wi-Fi 5. The 802.11ac standard was developed to provide higher data transfer rate, and improvement performance compared to its predecessor. Next is 802.11ax or Wi-Fi 6. This one is commonly known as Wi-Fi 6, is a latest wireless networking standard in the family of protocol. It is designed to improve upon the previous Wi-Fi standards, such as 802.11ac Wi-Fi 5, by delivering higher data rates, better performance in crowded environment, increased efficiency, and improve overall use experience. The last one is 802.11ay. As of my last knowledge update in January 2022, 802.11ai is a wireless networking standard that operates in the 60 GHz frequency band. It is part of the 802.11 family of protocols, and it is designed to provide high-speed wireless communication for specific use case. Next is wireless networking application. Span a wide range of industry and use case, taking advantage of the convenience and flexibility offered by wireless communication. Here are some common applications of wireless networking. The first one is education. Education at campus networks. Why? Because educational institutions use wireless networks to connect classrooms, libraries, and other facilities, allowing students and staff to access resources from anywhere on the campus. Number 2 is public Wi-Fi hotspot, like airport, cafe, and hotels. Why? Public space often offer Wi-Fi for visitors, providing internet access to people on the go. Next is healthcare. Wireless medical device. Many medical devices such as patient monitor and infusion pumps use wireless connectivity for data transmission to central system. Next, entertainment. Wireless streaming. Wireless networks support streaming service for audio and video content, allowing users to enjoy entertainment without physical connection. Next is retail. Wireless point of sale or POS system. Retailer use wireless network for POS system, inventory management, and custom engagement. Last one is home networking. Wi-Fi networks. Most home use Wi-Fi for internet connectivity, allowing multiple devices like smartphone, laptop, smart TV, and IoT device to connect wirelessly.
Importance of standardization bodies. First, role of organization. There are USB Implementers Forum, USB-IF, HDMI Licensing Administrator, Licensing Authorities, Institute of Electrical and Electronics Engineer. The example of collaboration are USB-IF Collaboration, HDMI Forum, Institute of Electrical and Electronics Engineer Working Groups, and Industry Alliance. For ensuring consistency and compatibility, there are interoperability testing, collaborative industry efforts, educations and guidelines, user education, and adaptive design. The last one is example of standard updates. There are USB standards evolutions, HDMI 2.1 specification, Institute of Electrical and Electronics Engineer 802.11x or Wi-Fi 6, and Bluetooth 5.0.
Challenges in standardization. Standardization, the process of developing, promoting, and implementing technical standards, can face various challenges. These challenges can arise from technological, organizational, economic, and social factors. Here are some common challenges in standardization. Number 1 is interoperability. Number 2 is lack of industry consensus. Number 3 is legacy systems and resistance to change. Number 4 is emerging technologies and uncharted territories. And the last one is intellectual property issues. There is several emerging technologies were making strides across various fields. Here are some technologies that were gaining momentum and were expected to continue evolving. Number 1 is artificial intelligence (AI) and machine learning (ML). Number 2 is 5G technology. Number 3 is Internet of Things (IoT). Number 4 is blockchain and cryptocurrency. Number 5 is edge computing, and the last one is quantum computing.
Trend ends. As of my last knowledge update in January 2022, I can provide insight into some general trend in external interconnection standard. However, please note that the technology landscape is dynamic and new development may have occurred since then. As of 2022, the following trends were noteworthy. USB power delivery or USB PD is a standard of enable higher power levels for charging device over USB connection. It allows for more versatile power delivery, supporting not only smartphone and tablets but also laptop and other devices. Next, USB Type-C connectors continue to gain popularity due to their reversible design, compact form factor, and support for various protocols including USB, Thunderbolt, and DisplayPort. Next, Wi-Fi standards such as Wi-Fi 6 or 802.11ax and its successor aim to provide faster wireless connectivity and improve efficiency in crowded network environments. Next, 5G connectivity as 5G networks roll out globally. There is a growing focus on defining standard for external interconnection to support high-speed, low-latency wireless communication. And the last one is PCI Express. PCI Express 4.0 and PCI Express 5.0 are the latest iterations of the PCI Express standard, providing increased data transfer rate for internal and external interconnection in computing system.
Finally, external interconnection standards serve as the tech world's universal translator. They ensure that our devices communicate efficiently with one another, making our digital life easier. Because of these standards, you can plug a USB into your computer or charge your phone with the same cable that fits into multiple devices. Their primary responsibility is to encourage gadget collaboration. It will be an archie if your smartphone, printer, and laptop all spoke different language. External interconnection standards ensure that devices communicate with one another, resulting in a pleasant and trouble-free user experience. These criteria also encourage businesses to concentrate on what they do best. Rather than creating the wheel with each new gadget, manufacturers can build on existing standards. This saves time and money while also resulting in better, more polished products. Consider external interconnection standards to be the tech industry backstage crew. They work hard behind the scenes to ensure that everything operates well, and for us, the users, these standards mean that we may enjoy a wide range of technological possibility without having to worry about compatibility difficulties. So, cheers to the standard that keep our digital world connected and usable.